This video discusses the different storage tiers and their characteristics. By the end of this, you should be able to identify the primary characteristics and purpose of each storage tier in Kinetica. Let's look at some general characteristics of storage tiers before we jump into each of them separately. The first two tiers, VRAM and RAM, provide in-memory storage, while the three below it provide disk-based storage. In general, the performance and capacity of storage tiers are inversely related. For instance, for most setups, the VRAM tier will usually have the smallest total memory, but be the most performant for processing data, while the cold storage tier would be the largest in terms of capacity, but also the least performant. Let's dive a bit deeper into each of these tiers, starting with the VRAM. VRAM, which stands for Video RAM, is the fastest and usually the smallest tier. Any operation that uses the GPU requires the data to be in the VRAM tier. There are a few things to note about the VRAM tier. The first is that it is only available for CUDA-enabled installations. And the second is that in a host with multiple GPUs, the data in the VRAM might need to be temporarily duplicated across the different GPUs due to restrictions on cross-GPU VRAM access. Next, let's talk about the second type of in-memory tier, the RAM tier. Every installation of Kinetica will have at least one RAM tier, and any data required for CPU-based operations needs to be loaded into it. A key thing to remember while sizing the RAM tier is to leave enough space for other processes running on the same host, and for variables used for program flow control or storing other metadata. Next, we have the disk cache tier. This tier is meant to serve as an intermediary cache that can hold data objects that are evicted from the RAM and VRAM tiers when they run out of space. These evicted objects can then be reloaded into the RAM when they are needed. The RAM and VRAM tier deal with two types of data, persistible and non-persistible. Persistible data are data that can be stored in the persist tier, while non-persistible data like join views, filter views, and memory-only tables cannot be stored in the persist tier. So when the in-memory tiers run out of space, they would need to evict these tables to create space for new data objects that are generated through user requests. Since the persistent data already exists in the persist tier, these can be removed from the in-memory tiers. But what about non-persistible data? This is where the disk cache tier comes in, the only disk-based tier that can hold both non-persistible tables and persistible tables. So while it is optional, it is recommended that every installation of Kinetica should have a disk cache tier. An important point to note here is that the performance benefits of using a disk cache tier is conditional on its speed. If the disk cache tier is not faster than the persist tier, then there are no benefits to caching persistent tables since they already exist in the persist tier and can be pulled in directly from there. However, even when this is the case, it is recommended to have a disk cache tier since it is still the only disk-based tier that can hold non-persistible tables, which would otherwise be evicted permanently. Finally, it is possible to have more than one disk cache tiers on different disks with different capacities and performance parameters. Next, let's look at the persist tier. As the name suggests, the persist tier contains persistent data that can survive database restarts. And like the RAM tier, every installation of Kinetica has a persist tier by default. There are two things to remember when configuring it. The first is that it needs to be big enough to hold all the operational data. And the second is that a size limit should be set on the persist tier only if you have configured a cold storage tier, without which operations that require space in the persist tier will fail once its limit is reached. The last storage tier in Kinetica is cold storage. Cold storage is typically a larger but slower physical disk or cloud-based storage system. It handles persistent data that overflows from the persist tier and is useful for storing infrequently used data. This brings us to the end of this video on storage tiers and their characteristics. In the next section, we will see how data is moved between each of these tiers.